This video will help you with problem number 6.77. I begin by introducing our binomial formula. This will help us find the probability that some binomial distribution, x number of successes out of an n number of possible trials. If you haven't viewed the first video from assignment number 9, it'll explain how to use this formula. 6.77 Industrial quality control programs often include inspection of incoming materials from suppliers. If parts are purchased in large lots, a typical plan might be to select 20 parts at random from a lot and inspect them. Suppose that a lot is judged acceptable if one or fewer of these 20 parts are defective. So we have this lot, some box full of parts, all right? And there are 20 total parts in this box. N equals 20. And we're going to judge this to be a good lot if no more than one are defective. So if none of these are defective, or if one are defective, we're going to ship them. We're going to say all of them are good to go. All right, so what do we want to find? It says find the probability of accepting the lots that have each of the following. 5% defective parts on average. So we don't know that there's exactly 5% defective in here, but in the long run, 5% of the parts are going to be defective. It's possible that all 20 were bad, even if only 5% are defective. Highly unlikely. But what we want to find is the chance that there are none defective, that is, x is 0, or there is one defective. So we have 20 total, that's our n. We want to know what is the chance that 0 are defective or 1. Well, let's use our formula. The probability that 0, x is 0, are defective, n's our total, that's 20 factorial. X, again, is 0. By definition, 0 factorial is 1. Again, watch the first video to help with this. N in this case, still 20. X being 0. All right. P is our probability of success. In this case, our success is a defective part. So that's 0.05. To the x power, that's number of successes. In this case, 0. 1 minus P, that's 1 minus 0.05, which is 0.95. N minus x, that's 20 total minus our 0. I'm going to do a little simplification here. You'll see that this is 1, and clearly 20 minus 0 is 20, so you have 20 factorial over 20 factorial, that's 1. What this term finds is the number of ways our situation can happen. Well, if we have no defective parts in here, there's only one way that goes down. All 20 of them are good. One scenario. This first term, sometimes called the binomial coefficient, and it's also the combination formula, just finds the number of ways that our particular situation can be written. In this case, there's only one way that we can have no failures, all 20 successes. Well, this is the number of successes, in this case, defective parts. We have no defective parts, all right? So that's 0.05 to the 0 power. That's also going to be 1. 1 minus 0.05, that's 0.95. This is our fails. In this case, a good part. So what we're saying here is 20 consecutive good parts, no bad parts, times 1. Using your calculator, that is simply 0.95 to the 20th power, and that's approximately 0.3585. Which is approximately 36%. So if 95% of our parts are good, 36% of the time, this box, this lot of 20 would all be good. So this is an important thing to just see in general. No matter how good you are at a thing, in this case, we're getting 95% of them. To get a lot of them in a row, to be successful 20 times in a row, is not very likely. So perfection is difficult is what we see here, all right? Even though we have a 95% chance of being successful, 20 times in a row, there's only a 36% chance. Well, now we need the probability that we have one success. Using the same formula, it's going to be 20 factorial divided by 1 factorial, 20 minus 1 factorial, times, again we have 0.05, that's our defective parts. This time we have one of them. 0.95 times our successes, 19. Notice that these two numbers will always add up to our total. 1 and 19 is 20. 0 and 20 is 20. Well, in this case, this will all simplify to 20. That is, there's 20 different ways to get one defective part. It could be the first one. It could be the second one. It could be the third one. 20 ways for that to go down. Times 0.05 to the first, times 0.95 to the 19th. Calculating this. Is 0.3773, or approximately 38%. Okay, so we could then now sum these two numbers, and that would be the answer for A. So answer choice A, we want the chance that x is equal to 0 or x is equal to 2, and that's going to be 0.3585 plus 0.3773, and that is 0.7359. This is answer A. All right, now I'm going to show you this formula can easily be found using a binomial distribution calculator. If you have a TI calculator, it has it on it, and I'm going to show that briefly. Here I'm using a TI calculator. I'm going to show how we can calculate this, either of these probabilities. Let me show our initial one. So, coming to your home screen, you can hit second vars, that's distribution. Second vars. I'm going to where it says binom PDF. This is the binomial probability distribution function. Then I hit enter. Now it says number of trials. Well, in this case, 20. Our probability P, our probability of success, 0.05. And our X value, the number of successes, well, let's try our 0. Okay. And this should return this 0.3585. Hit paste. If your calculator comes directly to this screen, you can just type that 20.05 and 0 in. And here you see it is 0.3584. That's the number that we have here. All right. Now I'm going to show you one that you could use online. If you simply search binomial distribution calculator, the top one will say binomial calculator stat track. Click on it. So now I'm on my binomial calculator. Probability of success for a single trial is 0.05. Number of trials, 20. Number of successes, 0. And this will give us all sorts of things. Here it says x is equal to x. That's our particular value. That's what we've seen on the previous one. Here is a cumulative, a less than or equal to. It can give all sorts of information that would be helpful. So in this case, I go calculate, and there's that 0.3585. Let's change this to 1. Now we can see that second number we got, 0.3773, but also we can see our answer here, 0.7358, because that is x is less than or equal to 1. So this is giving us the 1 and the 0. So this is the answer to our particular problem A.